number of zeros at the end. Number of zeros at the end. Lot of concepts I'll discuss. Number of zeros at the end. 10 power 1, it is nothing but 1 0 at the end. Number of zeros at the end is also called as trailing zeros. Trailing zeros. In the question, if it is highest power of, I did for 12, the answer is 2. Suppose if it is for the 12, answer is 2. For 24, good that Dharmender has just said answer is 2. For 24, answer will be 12, 18, now 24. Is there any other cases? 12 2s are 24. 24 answer is 1. Good that you reminded. 12 the answer is 2 and 24 the answer is 1. Is it clear? 12 the answer is 2 and 24 the answer is 1. Just replace the question with 24 with 12. You will get the answer 2. If you want 24, answer is 1. Idea clear, right? Right. Next one. Number of zeros at the end. 10 power 1 is 1 0 at the end. 10 square is 100. 100 has got 2 zeros at the end. 10 cube is 3 zeros at the end. 3 zeros at the end is nothing but the power of 10. 2 zeros at the end is nothing but the power of 2. 1 0 at the end is nothing but the power of 10. Number of trailing zeros. Number of trailing zeros. Number of trailing zeros. Number of zeros at the end is nothing but the highest power of 10. Number of trailing zeros. Number of zeros at the end is nothing but the highest power of 10. Listen carefully, sir. Number of trailing zeros is nothing but the highest power of 10. I hope the concept is clear. Now, first question. First one. 30 factorial ends with dash number of zeros. 30 factorial ends with dash number of zeros. Right? Dash number of zeros. Number of zeros at the end is nothing but the highest power of 10. Highest power of 10 in 30 factorial. 10 is nothing but 2 into 5. 30 it is nothing but 5 6 are 5 1s are 7. It is nothing but 2 15s are 2 7s are 2 3s are 2 1s are 11 26. 30 factorial is nothing but 2 power 26 into 5 power 7 into k. So this is nothing but 2 into 5 power 7 into 2 power 29 into k. 10 power 1 will give you 1 0 at the end. 10 power 2 will give you 2 zeros at the end. 10 power 7 will give you 7 zeros at the end. 10 power 7 will give you 7 zeros at the end. I hope the idea is clear. Number of zeros at the end. Now in some textbooks they will say that highest power of 5. Highest power of 5 only will give the answer. That also you can do it, but before that one, right, let me explain few more question. First question it is clear, right? Next question. Next one, keep listening carefully, sir. 30 factorial ends with a dash number of zeros. Next one. 100 factorial ends with dash number of zeros. One more example. 100 factorial ends with dash number of zeros. So it is nothing but number of zeros at the end is nothing but highest power of 2 in 100 factorial. Sorry, highest power of 10 in 100 factorial. This for I will boil down to highest power of 5 in 100 factorial. In this case both are same. Why? Because 10 is nothing but 2 into 5. So for 100 factorial, already we did so many times. We got 2 power 97 into 5 power 24 into k. So 2 into 5 power 24 into 2 power 73 into k. Answer is 24. 24 is nothing but the highest power of 5. 5 20s are 100, 5 4s are 20. So answer is 24. So first point please write down. First point please write down. First point, only for factorial based problems. Only for factorial based problems, number of zeros at the end is nothing but the highest power of 5. You don't need to do 2. Now we will write that point in a new slide. I hope it is clear. For factorial problems, determining highest power of 10 is same as highest power of 5. For only factorial based problems, for only factorial based problems, for only factorial based problems, number of trailing zeros, number of trailing zeros, number of trailing zeros is nothing but the highest power of 5. Only for the factorial based problems, number of trailing zeros is nothing but the highest power of 5. Sir, what happens if it is not factorial? That also we will discuss. Only for factorial based problems, number of trailing zeros will be equivalent to highest power of 5. Suppose for example, 150 factorial ends with a dash number of zeros. 150 factorial ends with a dash number of zeros. 150 is nothing but, no need of doing for 10 because it is a factorial. 5 30s are, 5 6s are, 5 1s are. 30 plus 6 plus 1. Answer for this question is 37. Answer for this question is 37. I hope the idea is clear. From here we will develop a lot of beautiful concepts. Few beautiful concepts which you will not find it in the regular textbook. That also I will discuss. That also I will discuss. I hope it is clear. Write one more question. Write one more question. Find the number of trailing zeros. Find the number of trailing zeros in 22 factorial plus 178941 factorial. 22 factorial plus 178941 factorial. So see here, another good question, sir. A number is given. What is the number? Number is 22 factorial plus 17814 factorial. This number is a part of this number. So if I take 22 factorial, I will get 1 plus something remaining. So I want a number of trailing zeros. Number of trailing zeros is nothing but highest power of 5. Highest power of 5. 1 plus something. 1 plus. So here if you observe 22 factorial into 23 and so on up to 17841 we will get. Here I will get 25. 25 is divisible by 5. 5 plus 1 number. This number is not divisible by 5. 5 plus 1 number. This number is not divisible by 5. That means this is only the highest power of 5. What will be the answer? 5 4s are 20. 5 zeros are 0. Answer is nothing but 4 plus 0. Answer is nothing but 4. I hope the idea is clear. Number of trailing zeros. Number of trailing zeros in factorial. In factorial. In factorial. I hope it is clear. Any doubt in this question? Any doubt in this question? Next, one more question. One more question. Please write down. One more question. I hope this idea is clear, right? Next one. Next one. Please write down one more question. N equivalent to 71, 72, 73, 74, 74, 75. Number of trailing zeros. Number of trailing zeros at the end. Number of trailing zeros at the end. It's a very simple question. Number of trailing zeros at the end. What will be the answer? Number of trailing zeros is nothing but the multiples of 10. 71, 72, 73, 74, 75. What is 5 2s are 10? 10. Only one 0 is there at the end. So answer is, there is only one 0 at the end. There is only one 0 at the end. I hope it is clear. Next one. Please write down an important note. Important note. This note is very important. This you will not find it in the regular textbook. Please write down. Note. N factorial ends with x zeros. N factorial ends with x zeros. Then n is always greater than 4x. Please write down this point. N factorial ends with x zeros. N is greater than 4x. I will also discuss a proof for this question. With an example, I will write it here. 100 factorial ends with, how much we got answer? 100 factorial ends with 24 zeros, we got the answer. What did we do? 100 we divided by 5. 5 20s are 100. 5 4s are 20. 20 plus 4 is 24. This we wrote it like this. Suppose if I write like this, number of zeros, if I call it as x. First I divided number by 5. Am I right? First I divided 100 by 25, which is nothing but 20. Then I divided 100 by 25. This is nothing but n by 5 square. If I get any decimal value, I ignored. 2.1, I wrote it as 2. Suppose see here. Suppose if it is 17, if I divide by 5, 5 is 5 3s are 15, 3.2. I eliminated it. Depending upon the value of n, it stopped. Is it clear? It depends. If n is 200, it will stop at 5 cube. 200 by 125 is 1. If n is 1000, it will stop at 5 power 4. This value will terminate. Can I say 1 plus 2 plus 3 is always less than 1 plus 2 plus 3 till infinite? So it is always less than, x is less than n by 5, n by 5 square, n by 5 cube, and so on up to infinite. And so on up to infinite. If I take n by 5 common, which is 1 plus 1 by 5, 1 by 5 square, and so on. X is nothing but n by 5 into 5 by a by 1 minus r. Instead of writing here, we will write it here. So it is nothing but x is less than n by 5, a by 1 minus r. 1 by 1 minus 1 by 5. So x is less than n by 4. 4x is less than n. N is greater than 4x. Please make a note of it, sir. Generally in the questions only factorial problems will be given. Number of zeros at the end is asked. But right now what I am doing is, I am giving you number of zeros I am giving you number of zeros at the end. Then I am asking you how to find out the number. Please write down this point. N factorial ends with x zeros. Then n is always greater than 4x. I will tell you its concept when we discuss. Otherwise, it will be very lengthy. This entire proof is to tell you that yn should be greater than 4x. Yn should be greater than 4x. N factorial ends with x zeros, then n should be greater than 4x. Suppose, example, write down this point. N factorial ends with x zeros. N factorial ends with x zeros. Then n is greater than 4x. Then n is greater than 4x. Suppose, for example, question n factorial ends with 6 zeros. How many values n can take? How many values n can take? N factorial ends with 6 zeros. How many values n can take? Directly you can solve the question by using this notation. What is the notation? N factorial ends with x zeros. N should be greater than 4x, which is 4 into 6, 24. Check for the next multiple of 5 greater than 24. If I take 25, 5 5s are 25, 5 1s are 5. 5 plus 1, 6. That means 25 will be the answer, 26 will be the answer, 27 will be the answer, 28 will be the answer, and 29 also will be the answer. 30 cannot be the answer because 5 6 are 30, 5 1s are 5. 6 plus 1 is 7. Directly we will get totally 5 values. If you, otherwise you have to enumerate it. Total 5 values you will get it. Total 5 values you got it. Are you all with me, sir? Total 5 values you got it. Any doubt in any of these logic? Any doubt in any of these logic? N factorial ends with x zeros. N should always be greater than 4x. So n is greater than 24. So what is the multiple of 5 greater than 24? 25, 26, 27, 28, 29. So answer is 5 values. Few more questions we will solve based upon this model. This is when the number of zeros are there given. At the end we are finding the number. Suppose one more question. N factorial ends with 17 zeros at the end. 17 zeros at the end. How many values n can take? How many values n can take? How many values n can take? N factorial ends with 17 zeros. Directly we will get the answer. N is greater than 4x. 4 into 17, 68. N is greater than 68. What is the multiple of 5 greater than 68? 70. 70 divided by 5. 5 14s are 70, 5 2s are 10. So we got 16 for 70. 70 will be 16. 70, 71. 72, 73, 74. If I take 75, 5 15s are 5 3s are 15 plus 3, 18. Here I got 16, here I got 18. But the question is 17. Answer is no, not possible. No value of n. No value of n. No value of n will give you 17 zeros at the end. No value of n will give you 17 zeros at the end. Dharmender, which thing you typed beta? I somehow ignored your message. Please tell me which question that you want to know. So n factorial ends with 17 zeros. N is greater than 4x, 70. 70 will give you 16 zeros. 70 to 74 will give you 16 zeros. But 75 will give you 18 zeros. 17 zeros, it is not possible. Right? I hope the idea is clear, right? Idea is clear. Kindly reply it in the live chat if the idea is clear. 16 to 18. 16, 9. Take the multiple of 5 beta. 16, 9 if I take. 5 1s are 5. 19. 5 3s are. Right? 13 only I am getting. 13 only. 13. 5 2s are 10. 13 plus 2, 15 only I am getting, Arvind. 15 only I am getting. I need to get 17. I need to get 17. I hope the idea is clear. Next one. Next one. Please write down the next question. Remember this, n factorial ends with x zeros. N factorial ends with x zeros. N factorial ends with x zeros. N is greater than 4x. Next question. N factorial never ends with. N factorial never ends with dash number of zeros. N factorial never ends with dash number of zeros. Another beautiful question, sir. Option A, 5, 6, 7, 8. 5, 6, 7, 8. 5, 6, 7, 8. Now let us solve it very logically. Suppose if it is 5. If it is 5. N is greater than 4x. So n is greater than 5 4s are 20. What is the multiple of 5 just greater than 20? 25. 5 5s are 25. 5 plus 1. How many zeros I got? 6. But I want 5 zeros. Not possible. 6 is possible. After 20, what is the multiple of 5? 25. Next one is 30. 5 6 are 30. 5 1s are 5. 6 plus 1 7. It is possible. After 30, what is the next multiple? 5 7s are 35. 5 1s are 5. 7 plus 1, 8 possible. 6 possible, 7 possible, 8 possible. What is not possible? Answer is 5. N factorial never ends with 5 zeros. N factorial never ends with 5 zeros. I hope the idea is clear. N factorial never ends with 5 zeros. Next, another variety. Another variety. Please put a star mark on this question, sir. Star mark on this question. Star mark on this question. M equivalent to product of even numbers from 1 to 25. Product of even numbers from 1 to 25. N is nothing but product of odd numbers from 26 to 200. 26 to 200. M into N gives dash number of trailing zeros. M into N gives dash number of trailing zeros. Extremely important question. M is product of even numbers from 1 to 25. N is the product of odd numbers from 26 to 200. M into N gives a dash number of trailing zeros. Please listen carefully to this question. M is nothing but product of even numbers from 1 to 25. 2, 4, 6, 8, 10 and so on up to 24. And so on up to 24. So 2 into 1, 4 is 2 into 2, 6 is 2 into 3, 24 is 2 into 12. 2 into 12. 2 is multiplied 12 times. So 2 power 12 into 1 into 2 into 3 to 12 is 12 factorial. So total I got 2 power 12 into 12 factorial. It is 2 power 12 into 12 if I take for 2. 2 6 are 2. 2 3s are 2 1s are 2 power 10. 5 it will be 5 2s are 10. 5 square. So m is nothing but 2 power 22 into 5 square into k. First write down this. M is nothing but 2 power 22 into 2 power 22 into 5 power 2 into 8. Till here clear, right? This is only for m. Why the star mark? In this question you will realize that number of zeros at the end is not always the highest power of 5. M is 2 power 12 into 12 factorial. This is what we got for m. Now n also we have to write. So I am taking a new slide, sir. M is nothing but 2 power 22 into, how much we got? 2 power 22 into 5 square into k, which is nothing but product of all even numbers till 25. 2 4 6 8 till 24, which is m. What is n value given? N is the product of odd numbers till 200. 27, 29, 31, 33, 35. Now, and so on up to 199. What do we require? M into n gives dash number of zeros at the end. Number of zeros at the end means only 5 and 2 I require, that's all. So I will not take all this, only 5 I will take. 35. Next is 45. Next is 55. Next 65. Next 75. Next 85. Next 95. Next 105. Next 115. Next 125. 135. 145. 155. 165, 175, 185, 195. Only this numbers I will take. Powers of 2 anyway it is not there. So if you observe closely, listen carefully, sir, to this question. I require number of 5s. 35 5 into 7 plus 1. 45 plus 1. 55 is 5 into 11. 65 is 5 into 13. This is 75 is 25 into 3. These plus 1. These plus 1. These also plus 1. These plus 1. These 5 cube. It is plus 3. It is plus 1. 5 into 20. Plus 1 is for this. 5 into 27. 45. It is plus 1. 55. 5 into 31 plus 1. 5 into 33 plus 1. 25 into 7 plus 2. 85 it is plus 1. 195 it is plus 1. So how many I got? 1, 2, 3, 4, 6, 7, 8. 1, 2, 3, 4, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 19, 21. N is nothing but 5 power 21 into K2. 5 power 21 into K2. M into N I require. M is nothing but 2 power 22 into 5 power 2 into K into 5 power 21 into K2. 21 plus 2 is 23. Which is lowest? 2 is lowest. The classic problem which explains number of zeros at the end is not always the power of 5. Number of zeros at the end is not always the power of 5. Today in this case we got it as power of 2. In this question, please put a star mark on this question, sir. Again I am explaining. M is the product of all even numbers from 2 to 25, 2, 4, 6, 8 till 24, which is nothing but 2 power 22 into 5 power 2 into k. N is product of all odd numbers. All odd numbers from 26 to 200. Odd numbers I took 27, 29, 31, 33, 35. But because I require number of zeros at the end, I require only 2 and 5. So 2 anyway will not come in odd number. I took it as a multiple of 5, 35, 45, 55, 65, 75, 85, 95, 105, 115, 125, 135, 145, 155, 165, 175, 185, 195. 35 is 5 into 7. 1 power of 5 will be there. 45 is 5 into 9. 55 is 5 into 11. 65 is 5 into 13. 75 is 5 into 15. 85 is 5 into 17. 95 is 5 into 19. 105 is 5 into 21. 115 is 5 into 23. 125 is 5 into 25. So here I got two cases, 25 into 3, 25 into 5, 25 into 7. So there I got two cases. Is this question clear to you? Number of 5s, number of 5, powers of 5 is smaller. Here in this case. Any doubt in this question? Any doubt in this question? Any doubt in this question? Kindly reply in the live chat if this question is clear to you. If this question is clear to you. Is this question clear? Clear, right? Now, next let us discuss few questions based upon this logic. This we have not discussed. We will discuss it little later. What all questions that we discussed? These all the third session slides. I think here you can solve one by one. Find the number of trailing zeros in 100 factorial. 5 20s are 100, 5 4s are 20. 20 plus 4 is 24. 50 is nothing but 5 10s are 50, 5 2s are 10. 10 plus 2 is 12. 20 is nothing but 5 4s are 20. Answer is 4. Lalit, where it is not clear, beta? I hope these three are very clear to you. Where it is not clear, specify. You want me to go back to that question? Which question you want? The same question? Are you referring to this question? You want me to explain again? How many students want me to explain again? How many students want me to explain this question again? M is nothing but 2 power 22 into 5 power 2 into k. This is M. N is product of all odd numbers. Odd number I don't require 41, 43. Number of zeros, it is dependent on 2 and 5. 35, 45, 55, 65, 75, 85, 95, 105, 115, 125, 135, 145, 155, 165, 175, 185, 195. Till here it is clear, right? This can be written as 35 as 5 into 7, 45 as 5 into 9, 55 as 5 into 11, 65 as 5 into 13, 75 as 25 into 3, 85 as 5 into 17, 95 as 5 into 19, 105 as 5 into 21, 115 5 into 23, 125 is 5 cube, again it is 5 into 27, 5 into 29, 5 into 31, 5 into 33, I hope you are all there with me, 25 into 7, 5 into 37, 5 into 39. Till here clear? This is where I wrote plus 1, plus 1, plus 1. 1, 2, 3, 4, here 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 19, 20, 21. N is nothing but 5 power 21 into K2. If I multiply m into n, 2 power 22 into 5 power 2 into k into 5 power 21 into k. 23, 22. What is the lowest? 22. Now I am sure it is clear to you. Now I am sure it is clear to you. Now I am sure it is clear to you. Is it clear? Is it clear? Idea clear? Idea clear, right? Now, Venkatramana, I hope it is clear, right? Lalit, I hope it is clear, right? Rohan Beta, I hope it is clear, right? Idea is clear? Now let us go back to few more questions. This is all session number 3. Session number 3 will be a very interesting high level question, sir. Now, these also we discussed. N factorial ends with 24 zeros. N is greater than 4x. N is greater than 96. What is the multiple of 5 just greater than 96? 100. 5 20s are 5 4s are. What is 20 plus 4? 24. So 100 will give you answer. 101 will give you. 102 will give you. 103 will give you. 104 will give you. How many values total? 5 values it will give. Total 5 values it will give. N greater than 4x. N greater than 96. What is the multiple of 5 greater than 96? 100. 5 20s are 5 4s are. So 100, 101, 102, 103, 104. Total 5 values I will get. Whatever we discussed, I am discussing that questions. Find the number of zeros at the end in. N is nothing but 1 into 2 into 3 into 4 and so on up to 500, which is nothing but 500 factorial. In 500 factorial, number of trailing zeros, only in factorials, number of trailing zeros is nothing but the highest power of 5. Is nothing but the highest power of 5. So answer is nothing but 500 divided by 5. 500s are, 520s are, 54s are. Answer is nothing but 124. Idea clear, right? 1 into 2 into 3 into 4 till 500, which is 500 factorial. 500 divided by 5. 500s are, 520s are, 54s are. 124. Very easy question. Find the number of zeros at the end in. What is the number present? 2 into 4 into 6 into 8 and so on up to 250, which is nothing but 2 1s are 2, 2 2s are 4, 2 3s are 6 and so on up to 2 125s are 250. 2 is multiplied 125 times. 2 power 125 into 1 into 2 into 3 till 125. Till 125, which is nothing but 2 power 125 into 125 factorial. factorial. In 125, how many 5s are there? 5 25s are, 5 5s are, 5 1s are. So which is 31? 31. Anyway, it will be greater. 2 power 125 into 2 power x into 5 power 31 into k. So answer for this question is 31. Answer for this question is 31. Idea clear, right? Number of, if the factorial is there, if only factorial is there, number of zeros at the end is nothing but highest power of 5. Number of zeros at the end is nothing but highest power of 5. Idea clear? Next one. Find the number of zeros in 1 3 5 7. 1 3 5 7 9. Again 11 13 15 17 19. Again 191 193 195 197 199. Number of zeros at the end is nothing but the highest power of 10. 10 is nothing but 2 and 5. 2 should be there, 5 should be there. All are odd numbers. All are odd numbers. So answer is no 0 at the end. No 0 at the end. No 0 at the end. I hope the idea is clear. No 0 at the end. All are odd numbers. To get the highest power of 10, you should get 2 and 5. There is no 2 in the question. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. No 0 at the end. Clear, right? Next one. Idea clear, right? Once you know the concept, these are all very, very easy questions. N factorial ends with 17 zeros. N is greater than 4x. Already we discussed. N is greater than 4x. N is greater than 68. I think the same question we have already solved it. 5 14s are, 5 2s are. 14 plus 2 16. 75 is 5 15s are, 5 3s are. 16 to 18. 17 is not possible. No value of n factorial ends with 17 zeros. No value of n factorial ends with 17 zeros. Idea clear, right? Idea clear, right? Still there are some more questions. Let us do these questions. Which of the following cannot be the number of trailing zeros? Trailing zeros means zeros at the end. Trailing zeros means zeros at the end. What is the concept? If you don't know this concept, in regular textbook this concept is not shown. N is greater than 4x. Let me put the first option. N is greater than 4 into 48. N is greater than 192. What is the multiple of 5 greater than 192? 195. 5 3s are, 5 9s are. 5 7s are. 5 1s are. 39 plus 7, 46 plus 1, 47. I got 47. 200. 5 40s are 200. 5 8s are 40. 5 1s are 5. I got 49. 47 to 49. Directly there is a jump from 47 to 49. 48 not possible. 48 not possible. I hope it is clear. 48 not possible. 49 it is possible for 200, 201, 202, 203, 204. 47 it is possible for 195, 196, 197, 198, 199. 50. N is greater than 4x. N is greater than 200. So if I take the next multiple of 200, 205. 541s are, 5 8s are, 5 1s are. 50 also possible. 50 also possible. Which all numbers? 205, 206, 207, 208, 209. Which answers? What is the answer for this question? It never ends with 48. Very, very important class, sir. Very, very important class. I hope you are all there with me. Number of zeros at the end. What is the condition? N factorial ends with x zeros. So then n is always greater than 4x. Then n is always greater than 4x. Then n is always greater than 4x. These are all very easy questions. Number of trailing zeros. 150 factorial plus 200 factorial, which is 150 factorial. If I take common, if I take 150 factorial common, 1 plus 200, 199 and so on up to 151 I will get. Are you all with me? Remaining is 150 factorial. This is divisible by 5. Divisible by, this is divisible by 5. 5 plus 1. That means bracket is not never divisible by 5. Bracket is never divisible by 5. Bracket is never divisible by 5. 150 factorial. How many zeros are there at the end? 5 30s are, 5 6s are, 5 1s are. Answer is nothing but 37. Idea clear, right? 150 factorial if I take 150 factorial if I take common, 1 plus 200, 199, 198 and so on up to 151. That means this entire number is divisible by 5. 5 plus 1 means 5k plus 1. 5k plus 1 is never divisible by 5. 150 factorial. 5 30s are, 5 6s are, 5 1s are. 30 plus 6 plus 1. Answer is nothing but 37. Answer is nothing but 37. Find the number of trailing zeros in 20, 30, 40, 50, 60, 70, 80, 100. If I take 10, 10 into 2, 10 into 3, 10 into 4, 10 into 5, 10 into 6, 10 into 7, 10 into 8, 10 into 10, 10 into 10. Totally how many tens we got? 1, 2, 3, 4, 5, 6, 7, 8. So 10 power 8. What is the remaining number? 2 into 3 into 4 into 5 into 6 into 7 into 8 into 10. This is the remaining number. So here it is 10 power 8. 2 into 5 is 110. Here another 10 is there. Remaining number is 3 into 4 into 6 into 7 into 8. This will not give me power of 10. 10 plus 10 power 1 into 10 power 1 is 10 power 2. So 10 power 8 plus 2. 10 power 10. Answer is nothing but 10. Answer is nothing but 10. I hope the idea is clear. The second class is primarily driven on the fact that how to find out the number of trailing zeros. N factorial ends with x zeros. N is greater than 4x. N factorial ends with x zeros. Then n is greater than 4x. I hope the idea is clear. Idea is clear. Any more similar questions are there? These are all advanced level. Today evening we are going to discuss. Today evening all these high level questions which we are going to discuss. We will do one more question. Which of the following can be the number of trailing zeros at the end of any factorial? What is the concept? N factorial ends with x zeros. Then n is greater than 4x. N factorial ends with x zeros, then n is greater than 4x. Suppose if I take 63, n is greater than 4 into 63. N is greater than 252. What is the multiple of 5 greater than 252? 255. 5 5s are 5 1s are 5 10s are 5 2s are 51 plus 1 61 plus 2 63. It is possible. That means this is possible for 55, 56, 57, 58, 59. These are all are possible. Next is B option, 68. N is greater than 4x. N is greater than 4 into 68. 272. If I take 275, 5 5s are 25, 5 5s are 5 11s are 5 2s are 66, 68. It is also possible. 275 to 279. 279. This is possible. This is possible. Next, N is 70, 80 we will take. N is greater than 320. If I take what is the multiple of 5 greater than 320? 5 6 are, 5 5s are, 5 13s are, 5 2s are, 78, 80. This is possible. Next, take N is greater than 74. 4 into 74. N is greater than 296. If I take 300, 60, 12, 2. All are possible. Answer is all of this. Answer is all of this. When we got 63 and 68 only, we can say option A and B are satisfying. So answer will be all of this. Answer will be all of this. When two options are satisfying, then only we can say that the answers are all of this. I hope they are all with me. N factorial ends with x zeros, then n is greater than 4x. N factorial ends with x zeros, then n is greater than 4x. This is the concept. This you can solve it. This is a take home question. You can solve it little later. This is a take home question, similar model. What is the concept? N is greater than 4x. Then n is greater than 4x. This is a session 3, session 3, session 3. This is also session 3. I think this you can solve it easily. These 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 125s are 500. 4 is multiplied 125 times. 4 power 125 into 125 factorial. So these are nothing but 2 square power 125 into 125 factorial. 125, how many 5s are there? 5 25s are, 5 5s are, 5 1s are. 5 power 31 into 125 2s, how many are there? 262s are, 231s are, 215s are, 27s are, 23s are, 21s are. 11, 26, 26, 57, 119. 2 power 119. So obviously it will be, answer will be for the lowest one. Lowest one answer is 31. Variety of questions. Right after the class, I think during the break, there are few students who has purchased the course. Access also is given. Access also is given in case if you want this kind of structured way of learning. One time buying the course useful for multiple times. In case if you want this kind of course, you can message me right after the class. Message me. Few students in the first session got close to 25% discount. Those who asked for it, I gave it. Those who are not asking for it, right, in case you can go to website and buy it at the price which is there in the website. Next one. I think these also you can solve it. Number of trailing zeros in 3 1s are, 3 2s are, 3 3s are. 3 3s are, 3 4s are, 3 120s are. So it is nothing but 3 power 120 into 120 factorial, which is 3 power 120 into number of trailing zeros means for factorial I just require for 5. 5 24s are 5 4s are 5 power 28 into 2 will be something x. It will be more. Answer is 28. Answer is 28. Session 3 will be a very advanced level question. Session 3 will be a very advanced level concept. Session 3. These are all session 3 questions. Session 3. You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.